This video is going to have a look at water testing. By the end of it, you will be able to tell me what the difference between qualitative and quantitative analysis is. You'll be able to tell me why we need to test for anions and cations and the different tests that we can possibly do. So the first key word you need to get your head around is qualitative analysis. Basically, qualitative analysis tells you what is present. It doesn't tell you how much. So for example, it's like pH paper. Using pH paper you can find out whether something is an acid or not, but it doesn't tell you how much of an acid there is, the concentration of it, and the strength of it. So for example, litmus paper turns from blue to red in the presence of an acid. That doesn't tell you the strength of the acid, doesn't tell you the concentration and how much there is. Quantitative analysis, however, tells you how much there is. So that might be a titration, and it will tell you how much acid you need to neutralize an alkali. And from that you can work out the concentration, volume, etc., etc., which is what you'll be doing throughout this topic. So why is water testing important? Before water gets to us through our taps, it has to go through strict filtering and strict testing regimes. If that doesn't happen, there could be ionic compounds in there which could be dangerous to us. Now, some of them aren't really an issue, but there are some that can be dangerous, so it's important that we know what's present in the water and how much of it. So the first thing we're going to have a look at is qualitative analysis, which is going to tell us what's present. The first test that you need to be able to know is for the cations. Now this test is the flame test. I'm not going to go through in this video how to do it because you will have seen it in the additional chemistry. But if you do need to see it, I will put a link to the video below. What you need to know from this is what the test is, and then how you can test and know that sodium, potassium, calcium, copper, lithium and strontium are present. And that's by having a look at these flame colours here. So sodium gives you an orangey yellow, potassium a lilac, calcium a brick red, copper a bluey green, and lithium and strontium both give a crimson red flame. The second test, which you will have also seen before, is precipitate reactions. Now this will tell you other cations, and it will tell you mostly transition metal cations. So what you do is you take two soluble solids, and the aim is to produce a precipitate, an insoluble solid. So in this case I've got copper sulfate, and if I add sodium hydroxide to it, I get a blue precipitate, which is copper hydroxide, as you can see from the word and symbol equation below here. This is your precipitate, your solid, which is formed at the bottom. Now what you're expected to know is when you add sodium hydroxide to any of these cations, the colours that you get, which are... So, if you have a calcium ion, you'll get a white precipitate. Copper, as you've just seen, is blue. Iron 2+ gives you a dull green. Iron 3+, a reddy brown. Aluminium 3+ gives you a white, which then turns colourless. And then ammonium doesn't give you a precipitate, but it does give off ammonia when heated, which you'll see in a later PowerPoint. So make sure you know these tests, because they will come up, a lot of them in the additional and in the triple science.